Absolute value. I want to make sure you're clear on the definition of absolute value. So I'm coming over here. The absolute value is a piecewise defined function. And that's one thing you want to really make sure you're clear about, is that it's actually a piecewise defined function. If the number that's being absolute valued is positive, the absolute values weren't needed. And just whatever that number is, that's what that number is. But I want to make sure to clarify for you this piece right here. If x is a negative number, another way to absolute value, if you know it's a negative number, is to multiply it by a -1. So this bottom line is basically saying, if you know that x is a negative number and you want its absolute value, you can multiply it by -1, and that will give you the same thing. And I want you to also be aware that absolute value means that you are dealing with either a positive x or a negative x. If I take out being very specific about the domain, that's what that function comes down to here, is that it's either positive or negative of x. But if you ignore the domain, that's when you get extraneous solutions. And I want to make sure you're clear that extraneous solutions, they're solutions obtained by seemingly correct means, but it actually isn't a solution. And it should bother you that you get extraneous solutions when you think you're doing all the correct work. But know that the reason behind it is because certain algebra rules are sometimes ignored for the sake of the problem being a much simpler to solve problem. So it's actually to your benefit. Now, the easiest way to solve absolute value equations is to just turn it into two equations and ignore domain. So you turn it into two equations. By first isolate the absolute value. So with example 1, you needed to add 6 to both sides to get the absolute value by itself. And then either what is in the absolute value is positive, and you just don't need to have the absolute values, or what's in the absolute values is negative, so you take that same expression but multiply it by a -1. You really don't want to have to deal with the domain. It honestly is preferable here to just check for extraneous solutions in the end. Write those two equations and then solve those two equations. Now, as far as checking these solutions, you at least have a calculator on you. You can take the number, plug it into x, and think about, in the end, when you take its absolute value, are you getting positive 24? And then do the same thing with the other number. And right here, what I'm trying to show is that process taking place of checking for extraneous solutions. And this is, checking for the extraneous is far preferable from trying to deal with this from a piecewise function point of view and keeping the domain all in check and everything. So Let's look at then the second example. First, you need to isolate the absolute value. So you're going to divide by 3. And some of you might be in the habit of going, that means x plus 2 is equal to positive 5 or negative 5. If you don't do things exactly the same way that I'm showing you, that's fine. I know there are certain ways that you are taught how to do this. The way that I'm approaching these problems with you is I want you to make sure that you see why you're making the steps you are making. If you understand why you make the algebra steps instead of just memorizing, when I see that symbol, go plus or minus number over there and we're all good. If you understand that what you're doing is saying either this expression is positive or that expression is negative, any way that it makes sense to you, you can go through the work. And then you can take a look at what the solutions are and see how to check. Are you ready for the next piece? Okay. Absolute value inequalities is another issue. Now, I want to point out, you may have already memorized how to solve absolute value inequalities, and if you still remember how to do it, then that is fantastic. What I'm attempting to do is make sure that you understand what you're creating. So, coming over here, know that the actual definition of absolute value is a number's distance from 0. And with the word distance, distance is always positive. Now, with this next bit, I want to help you understand the two situations. The two situations are dealing with less than versus greater than. If the absolute value of x is less than the number 3, then it's within 3 units of 3. Now, the easiest way to rewrite this inequality, if you look at the picture, this is saying x is in between, and then you can take this number, positive and negative. That is the easiest way to solve the absolute value being less than. Now, I go into some deeper explanations if you read over things that I have written, but I want you to know that with the less than issue, that is your simplest way. When it comes to being absolute value of something being greater than, if you recognize that it means further than 3 units from 0, you can see that it's creating two separate inequalities together where both of them work. And if you remember, the word or with an inequality means that both inequalities are part of the solution. And you can write the word or you can write the union symbol. either one is good. So now I'm coming back over here. And let me see what I actually wanted to do with that. When you have an absolute value equation, it's not going to be just x, it's going to be some expression in the absolute values. I want to say this is the easiest way to go about solving it, is to start it off this way. What I'm referring to over here is the original definition that I gave you as a piecewise function. That original definition said either what you have in absolute values is positive, or it's negative and you multiply it by a -1. But if you go with the visual understanding, you take this, and it is much easier to do than an and inequality. With an and inequality, that means both have to be true to be part of the solution. Now, I want to say that I know how you are usually taught to work with the greater than issue. I want to, though, emphasize that you are usually told the next step in the process. However, if you remember the piecewise definition, the expression in the absolute value is either positive, and so I can just take this expression and write it exactly as it is without absolute values, or that expression is negative. Give me 1 second. If this expression happens to be negative, then you need to multiply it by a negative number, but you don't need to make any changes. Most people have a memorized way of dealing with absolute value inequalities. You're at a level in math where you can begin to understand what this is saying. All I'm doing is changing absolutely nothing except that what's in the absolute values either doesn't need absolute values or needs to be multiplied by a -1. What you're used to doing is taking what's in there, writing whatever it is greater than, and then flipping the sign and making it negative. But I want you to see this step right here, and that when you multiply both sides by -1, it creates this other one. But I've seen too many times that people memorize just to throw this out there without understanding what absolute value means. And the wonderful thing about math is you actually don't have to memorize as much if you understand what's going on. And that's when it runs more smoothly. Now, it is time to look at some examples. First, identify whether you're dealing with a greater than or a less than situation. And there's a fun little trick that you can use, which does tend to help people. This absolute value is greater than the number. This is that or situation. With the or situation, you're going to write down what's in the absolute values and just keep everything as is. Write the word or you can write the union symbol, whichever one you want to use. And then I want to point out to you that if you understand that either you multiply by a negative or you don't multiply by a negative, you create this step. I am okay if you don't write this step, because I know a lot of you are so used to doing this that you're ready to just do it. But make sure you understand why you flip the sign and multiply that number by a -1. Once you get the two equations, then it's just a matter of going through and solving them. So I'm going to go over to the work.
Wouldn't the -3 or the 3x be turned into -3x?
Well, if it depends on the order you do things in. What I'm showing you is you've got a negative with a parentheses here. And if I multiply the negative over to the other side, then that just lifts it from the parentheses. And I want to present to you different ways you can go about solving these inequalities. You need to find the way that makes sense to you and do it your way. If you're really good with the way that you have learned it and you remembered it right away, use that. So I tend to just kind of write this step to make sure people are clear about the math that's going on, and then you can immediately just multiply the negative to the other side. Either that or you can distribute the negative through. It's up to you. However, how should I say it? Yeah, never mind. I won't bother you with too much. I want to show you this. I do not expect you to do this checking right here. I want you to know that. I'm not going to expect this. If you are one of the people who really is into math and actually thinks you want to keep going in math, you can take a good look at this and see how this is checking for extraneous solutions, because we did ignore domain. The thing is, though, I'm only going to give you simple problems where you don't have to worry about the extraneous issues with the inequalities. With the equations, there will be extraneous issues here and there. But with the inequalities, I'm only sticking to the simpler ones. But I want to just kind of point out to you that this is how you can check that you have found the correct solutions. Okay, then let me come back and let's do number 4. Let's do number 4 the easy way. You can look at the notes to see the hard way. I think I put both the hard and the easy way. If you have absolute value less than, it's an and situation, but the easier way is to write what's in the absolute values and put it in between the positive and the negative of that number. And then you can treat this as a 3-side situation. You have your variable here, and you're isolating your variable. So you add 8 to all 3 sides, and that gives us -12. and then divide by 4. And you're going to write the solution in interval notation. Okay, my pen stopped playing with me. There we go. And also graph the solution on a number line. So just to finish up this problem, interval notation would be round brackets. And when you make your number lines, you don't need to worry about spacing the numbers anywhere on the number line. Just basically write them in somewhere. And if it's not including endpoints, open circle. If it does have the or equal to, fill in the circle. And actually, oh, was that the end of the classwork? Oh my goodness. That was the end. Now, you have a homework assignment that I still need to post, and I will be posting it in a moment. Or actually, once class is over, I'll post it. But let me just point out to you the items on your homework. Make sure you're ready for the homework assignment. So you have some solving absolute value equations, some inequalities. Again, you can go about solving any way that you like. If you are a person who can actually do the whole solving in your head, if I have a quick conversation with you at some point before testing, I can see whether you are actually capable of that or not. But I want to say when it comes to showing work on tests, a lot of the reason for showing work is so that if you have incorrect answers, I can figure out what you did wrong and give you partial credit. Whereas if you just write an answer down, I don't know why it's a wrong answer if it's wrong, and I can't give you any partial credit points. So then when it comes to factoring, you have more factoring practice. Leading coefficient 1, recognizing the perfect square trinomials, the difference of squares again, and now everyone's favorite, having a leading coefficient that is not 1. These are trickier problems. These are definitely trickier problems. And we've got enough time that I can go over an example, but I don't want to do one of the homework problems because I want you to try that on your own. So I'm going to just give me a second, and I'm going to actually, no, hold on. 1 second. I didn't think I was going to get through all of that, so I didn't have this ready to go. Give me 1 second, and I'm going to show the screen again. How do we know when we were supposed to use the or and and? Got it. Let me go back over to that. Finding So what you're looking for with the and or the or is whether you're dealing with absolute, and it's a fun little trick on words, and I just realized I can't write on this. Come on, Ben, work with me. My pen stopped wanting to play. Sometimes when I just click on a few things, it wakes back up. There we go. Okay. If your absolute value is greater than the number like this is, it is greater, and you have your or situation where you have to set up two separate inequalities. Then right here, the absolute value is less than, and that's the and situation that's more easily done as this trio right here. With people leaving, I'm guessing our time is up. I am so bad at Fridays. I have to find my calendar every single time. Period 2 is over at 11:05. No, it is not time to leave. Why are people leaving? Oh my gosh, you can't.
We're not able to see your screen if you're trying to.
Thank you. Yeah, I was. Yeah. Okay. So now my pen's not working again. Click, click. Yeah.
So when we see like absolute value in one of the solve each inequality problems, that's when we use the and or?
Yes.
Okay.
When it's an equal sign, it's much easier to deal with. And I am now getting officially frustrated with my pen. And I don't know why it sometimes just won't respond. There we go. Now it's responding suddenly.
When
Yes.
you see an absolute value equation with like a regular number just outside of it, do you want us to distribute it?
With a regular number outside of it, are you referring to
the homework?
Okay, let me look at the homework and see what you're referring to.
Yeah.
Okay. So what you really want to do is isolate absolute value first. Subtract that 2 to the other side. If you don't do that, it's most likely going to come out wrong.
What about number 4?
With number 4, actually with this 4 outside, if you wanted to, you could distribute it because it's multiplication that can distribute over a parentheses.
Okay.
I would recommend dividing it, but you don't have to.
All right, thank you.
Mm-hmm. So right here, when you subtract the 2, you're going to see absolute greater. So it's an or. Here, the absolute value is less than, so it's the and. And let me go back to pointing out to really understand that difference between the two. Look at these examples that I have right here with thinking about what it means to have an absolute value that's less than means that you're within a distance, but greater than in an absolute value means that you are further than that number in a distance from 0. And that might help with remembering which one is which. Now, I see that it is 11:05 now. if some of you want to be reminded of how to do factoring when you have a non-1 leading coefficient, stick around and I will go through this with you. Because I know that this one is a struggle for a lot of people. I start off with the diamond, where I do A times C, so that's negative 30. And then the B number is 13. Now, the tough part is you really do have to just kind of search through pairs of numbers until you find the right pair. But start off with the fact that you have negative 30 and you need a pair of numbers that will multiply to make negative 30. So what most likely comes to mind is, say, 5 and 6 make 30. So basically just make one of them positive, one of them negative. Because I'm needing to add to make a negative number, to add to make a positive number, I want the larger one to be the positive version. If I add these two numbers together, I get 1. That's not 13, so it's try again. And that's literally what this has to be, is try again, until you find the right pair. But then thinking about it, 15 times 2 will get you to 30. Make the smaller number the negative, and if you add those together, you do get 13. So that allows you to find what these special numbers are. But that then takes you into the box method. With the box method, you're going to figure out what the factors are. The factors are going to end up being what come into these 4 spots. You're going to take this polynomial, and the upper left corner gets the x squared term. The lower right corner gets the constant term. And the middle term is split up between a 15x and a negative 2x, and it doesn't matter which order you write them in. But you do that diamond so you can figure out what these two numbers are. Then what you're looking at is you can find any one of these 4 first. I'll just start here. You want to look down this column. Do you see common factors between the 2 terms in that column? Do you see a number that will divide? 3 will divide both of them. And then what else is in common? They both have x's. So you're looking for what are common factors between these terms. And I have to admit that this isn't necessarily going to always find you exactly right away what you need to do. There are complicated problems, and I'm going to try and stay away from the more complicated ones, where what you start off with might not actually work. But once you find one of those 4 spots that I had highlighted, then the game is on, because now you are looking at 3x times whatever is here gives you 6x squared. So 3x times what gives you 6x squared? And that would be 2x. Then come down here. 3x times what gives you 15x? And that would be 5. And now cross your fingers, because now you're looking at this negative 2x comes from multiplying this 2x by what is here. So that needs to be -1. And here's the real cross your fingers point. Do -1 times 5 give you this box? If so, you are factored. If not, then you have to go back to you have to kind of restart this. But I'm not going to give you the tough ones where there are different ways that it'll show up. But that gives you the factoring 3x minus 1 times 2x plus 5. Okay. Have a good weekend.
Thank you. Bye.
Yes. See you later.